children. Now today we will discuss with the upthrust is equal to the weight of the liquid displaced. Upthrust is equals to the weight of the liquid displaced. So now to understand, now let us discuss about this point first of all. Now if a body is immersed in a fluid or in a liquid, when a body is immersed in a fluid, the body experiences upthrust. You know that when a body is immersed in a fluid, the body experiences upthrust. And this upthrust experienced or exerted by the body is equal to the weight of the liquid displaced by the immersed part of the body. Now how to understand this? You just say that when a body is immersed in a liquid, the body will experience upthrust, and this upthrust is equal to the weight of the liquid displaced by the immersed part of the body. You just model it up. But what does it mean? Now this, as you know, that upthrust is equal to the weight of the liquid displaced by the immersed part of the body. Just remember that 2 points. Upthrust one, another point is weight of the liquid displaced by the immersed part of the body. So considering these 2 cases here, you take a kettle. Okay, you take a kettle. Kettle means, you know, a container having a spout. Fill the kettle with the water, and you fill in such a way that the water will not get overflowed. Okay, the water will not get overflowed. So you fill completely, you fill the kettle completely with water so that the water will not get displaced or overflow, and keep it. Now you bring a stone. You just put a stone, you tie a stone with a thread, and you just put a stone inside the water. You immerse the stone inside the water and consider that stone as a body. Once the stone is immersed in a water, the stone will experience upthrust. You know that. The upthrust is exerted by the liquid on the body because the downward force is more. The upward force is more than the downward force due to the height of the water volume. You know that. So now once you put a stone inside that kettle, what you will observe is that the water will come out from the spout. That is, the water will pour out from the spout. Now why the water will pour out? But before that, it was that was not happening before. The water is inside the kettle only. But once you put a stone or immerse a stone in a kettle, the water will overflow. Now what happens is that before the entire space was occupied by water before. Second case, when you put a stone, now some portion will be now occupied by the stone. Some portion in a kettle, some portion of it has to occupy by the stone, and there is no place for the water to remain inside the kettle. Okay, and therefore the water will come out. Okay, and that water which comes out from the spout of the kettle, that is the displaced water. And that water gets displaced when the body is immersed in a fluid or in a water. Okay, and what happens that displaced liquid, the weight of that displaced liquid, you just measure the weight, okay, of that liquid which has come out from the spout. You just measure the weight, find the weight, and that weight of the displaced liquid is equal to the upthrust. Okay, whatever the amount of water which has come out from the spout of the kettle, that weight of that displaced water is equal to the upthrust, which means that. So this is how this point has been explained. So therefore, when a body is immersed in a water, in a fluid, it experiences upthrust, and that upthrust is equal to the weight of the liquid displaced by the immersed part of the body. Because the liquid will displace, the liquid will come out to the spout only after when a body is immersed in a liquid. So it means that. So let us come to the mathematical calculation for that. So first of all, you take a vessel, okay, fill with the water, and put a cylindrical, you put a cylindrical body here, PQRS, and you just immerse inside the fluid. And this cylindrical body has got two faces, the upper face and the lower face. Upper face PQ and the lower face SR. In the upper face PQ is at a height of h1 and the lower face SR is at a height of h2. And this height is more than the height h1. Okay? And let us consider the pressure exerted. Here, the pressure exerted in the downward direction and the pressure P2 exerted in the upward direction, P1 exerted in the downward direction, and the forces F1 and F2 will also exert. Okay? So now, let us find the pressure at the depth of H1. First, you find the pressure at this depth. Okay, so to find pressure, we know that pressure equals to height into density into acceleration due to gravity, which we have done that. So P equals to H Pg. P means the density. Okay, now let us consider the cross-section area of this cylindrical vessel is A, cross-sectional area. PQRS is a cylindrical vessel having a cross-sectional area A. Okay, so now let us first calculate the pressure at the depth of H1. So pressure at the depth of H1 means that is at the height of pressure on this PQ. Okay, pressure at PQ will find it. So P equals to, the formula is here, P equals to H. H is height, H1 P G. Okay, so P is the density. Let us consider the density of the liquid P and acceleration due to gravity G and height is H1. So first we calculate the pressure. To calculate the pressure at the height of H1, that is at the uppermost part of this cylindrical vessel PQ. So P equals to H1 Pg. Then again, the thrust will be exerted here. Okay, thrust is the force. So force equals to, so we know that pressure equals to thrust divided by area. So thrust equals to pressure into area. So let us consider the thrust which has an existing pressure is all exerted here and downward force will also exert here. So let us find the downward force F1 equals to pressure into area. So what is pressure here? Pressure equals to H1 Pg into A. Make this as equation 1. So this is, so we have calculated the pressure at the height of H1 and the thrust or the force at the height of H1. Second one again. Again we find the pressure at the height of H2. So P equals to H2 Pg. Similarly again we calculate the force here. Force F2 equals to H2 Pg. Make this as equation 2. Okay, so we have calculated both the cases. We have calculated force as well as the pressure. Now what happens is that what the force point is on this side, on the side wall. Okay, on the side wall of this container, the thrust which is exerted will be same. Okay, but here thrust is different. Okay, the thrust is different. The upper force will be more here. Why the upper force will be more is that because the pressure is more. Greater the pressure, okay, the pressure increases with the depth. The pressure will be more at the region SR. Here the pressure at the region PQ is given as F1 Pg. Force at the region PQ, force equals to pressure into area. You know the formula. So pressure already given H1 Pg into A. Cross sectional area we are getting as A. Then P equals to H2 Pg. Okay, P is the density. Okay, this P is the density which we rated as rho, RHO rho. Okay, and F2 equals to H2 Pg. A will be as equation 2. What the thrust, and we have to calculate the thrust also on this case. ES and QR on this region. On this region, the thrust will be same. Equal thrust will be here. Okay, but here the thrust will be different. In the upper face and the lower face, pressure will also be different. So, but when we consider this wall of the cylindrical vessel, here the thrust will be same because they are at an equal depth. Okay, both of them are at equal depth and equal height. So, therefore, the pressure, the thrust at this region, PS and QR are same. Okay, so now we know that from this point of view, we know that F2 is greater than F1. Then again, P2 is greater than P1. So from this equation, what we found there? So F2 is greater than F1. So the upward force is more than the downward force. Then again the upward pressure is also more than the downward pressure. Okay, now after that what you calculate is that now you calculate the resultant force. Okay, now you calculate the resultant upward force. So the resultant upward force, how will you calculate? Now the resultant upward force, total upward force you have to calculate. So to calculate the resultant upward force, what we have to do? FB. So we have considered here FB is the buoyant force for the upthrust. FB is the buoyant force or the upthrust or the upward force. So therefore, the resultant upward force FB is equals to F2 minus F1. Okay, upward force is equals to F2 minus F1. The resultant upward force you will subtract it F2 minus F1. So why I am writing the F2? Because the F2 is greater than the F1 and P2 is greater than P1. So therefore, what is F2 here? F2 equals to H2 PGA minus F1 is given here H1 PGA. Okay, then what you can do is that now FB equals to, you can take common here. Okay, A you can take common. Here. H2 minus H1 into PG. Okay, so I have taken area as common because they have got a same cross section area. So FB equals to, so what A H1 minus H2, this give as a volume. Understood? So this, the entire portion, this area into H2 minus H1 will represent volume. So now I will write here VPG. So FB equals to VPG. So FB is the net upward force. So this net upward force is equals to volume into density of the liquid multiplied by acceleration due to gravity. Okay, so this way you will calculate the net upward force exerted. Okay, net exerted by the liquid on the innermost part of the body is given by VPG. V is the volume, P is the density, and G is the acceleration due to gravity. Okay, so this is the mathematical proof that the upthrust is equal to the weight of the liquid displaced. So from here we can find here that upthrust equals to weight of the, you can find it also weight of the liquid displaced by the submerged part of the body. Okay, so upthrust equals to weight of the liquid displaced by the submerged part of the body. So this way you can calculate here FB equals to, FB means that is the upward force for the upthrust. So upthrust equals to volume into V into G. Okay, so this is the mathematical proof, and remember that formula when you solve the numericals. Okay, when the body is immersed in a fluid, if you are required to find the upthrust, if you are required to find the volume, okay, or these two you can find here, you can either find the upthrust, directly you can use this formula, or if the upthrust is given, if you are required to find the volume, then you can use it here, FB equals to PG, or V equals to VPG equals to FB, or V equals to upthrust divided by what you can do here, density and acceleration due to gravity. So from this is the main equation here. So from this equation we can find upthrust also as well as the density of the liquid.